Hey, firstly, let's talk about a complete graph. Complete graph means every node, every dot, every vertex is connected to every other vertex. So here in the blue, we'll have an example with n equals 5. There's 5 vertices, there's 5 nodes. So I have to connect every one of these 5 nodes with every one of the other 5 nodes. So this first one's going to be connected here, here, here. I'll make that node bigger because it's hard for me to draw. There. So I connected this first node with all the other nodes. So if n equals 5, out of each node, I drew 4 lines. So every one of those 5 nodes, is going to have 4 lines coming out of it. So now let's do this one. I don't have to connect to this first one. Just connect here, connect here, connect here. So now there was only 3 lines coming out. This next one, I've already got 2 lines drawn, so I only have to do these other 2. This last node, I only need to make 1 line, and this node, I don't have to do any connections. So really, this 5 times 4, this 20 lines, I didn't draw 20 lines because each one of these lines, each one of these edges was double counted. So 5 times 4 divided by 2, there's really 10 edges in here. And yeah, okay, it looks like I'm summoning Satan or something, but that's a complete, we call that K for complete, subscript 5, that's K5. That's a complete graph with 5 nodes in it. And so there's 10 edges. So the formula was the number of nodes, n, times n minus 1 divided by 2, so we double, because we're double counting. Let's look over here in the red. This is, I don't know how many nodes there are there. I'm not going to count them. There's n. Out of each one of these nodes, I have to connect this node with all the other nodes. So every one of those nodes is going to have n minus 1 edges going out to it. The 5 times the 4, the n times the n minus 1, but I'm going to end up double counting because when I go to connect this node to all the other nodes, I've already counted that edge. So the number of edges in a complete graph is going to be n times n minus 1 divided by 2. And that would be a graph K sub n. So complete graph means every node is connected with every other node. And there's n times n minus 1 divided by 2 edges in a complete node. In a bipartite graph, we've got 2 different kinds of nodes. We can call them top nodes and bottom nodes. We can split the nodes into 2 pieces. Every top node is connected to every bottom node. So there's 3 bottom nodes, so out of every top node there's going to be 3 lines. 3 lines. And 3 lines. 1, 2, 3. So now every red node, the bottom nodes, is connected to every top node. So now if we want to know how many edges there are, there's 4 top nodes, and out of each one of these comes 3 lines, so that's 12 edges. We don't have to do the double counting thing because I'm only, let's say, drawing from each one of these top nodes to each one of these bottom nodes. Or I could have done it the other way around, right? It could have been there's 3 bottom nodes, and out of every one of these bottom nodes is 4 edges, so there's 12 as well. So that's bipartite. Notice none of the top nodes are connected to any of the other top nodes. None of the bottom nodes are connected to any of the other bottom nodes. So that would be a bipartite graph, as opposed to the complete graph where every node is connected to every other node.